What is inflammation? Before getting into inflammation and inflammatory response, let's go back to the origin of the concept of inflammation. During the 19th century, these two incredible guys, Rudolf Virchow and Machnikov, put forth the concept of inflammation. Virchow was the proponent of the view that inflammation is a pathological process, while Machnikov proposed that inflammation is beneficial and there is a whole spectrum of inflammatory response that led to his famous triangle, the Machnikov triangle. Inflammation is a spectrum containing homeostasis, physiological inflammation, pathological inflammation, and immunity. Let's dissect this triangle to see how these different parts relate to each other. So let's start from the bottom up. What is homeostasis? Homeostasis maintains the stability of a biological system in the face of perturbation. For example, in this sketch, the green ball indicates the desired state of a system. If the system deviates to the right or left, the negative feedback mechanism kicks in to restore it to the desired state, defined by some homeostatic set point. However, if this deviation goes beyond the point where homeostatic mechanism could not handle the perturbation, inflammation turned on. And this inflammation is a protective physiological inflammation that put the system back to the desired state. But this protective inflammation has the capacity to push the system outside the normal range, resulting in pathological inflammation, including acute and chronic inflammation. In case of chronic inflammation, an alternative stable state is attained that could lead to a number of chronic diseases. This pathological inflammation will activate the immune system, both innate and adaptive immune system, depending upon the severity of inflammation. Now, what are the common causes of inflammation and how the body responds to them? The response could be normal or excessive. For example, in infection, the body would respond normally to defend against infection. And the excessive response would be collateral damage, sepsis, and autoimmune diseases. The noxious substance would get a normal response to get rid of it. And the excessive would be the development of allergies. In case of tissue damage, the body would try to repair the tissue. And the abnormal would be the development of fibrosis and cancer. The modern lifestyle is also one of the causes of inflammation, and it would only lead to metabolic, cardiovascular, and age-related diseases. So, what are the components of the inflammatory response? These are inducers, sensors, mediators, and effectors. Inflammation could be induced by pathogens, tissue damage, and loss of homeostasis that led to the activation of sensors, including macrophages, mast cells, and sensory neurons. The activated sensor release various mediators like cytokines, chemokines, bioactive amine, peptide, eicosanoids. These mediators then act on different effectors like liver, blood vessel, and neutrophils in order to remove either the pathogen or repair the damage or return the system back to homeostasis. These components induce inflammation through four distinct steps: recognition, recruitment, removal, and repair. After the inflammation is induced through either pathogen, tissue damage, or loss of homeostasis, the recognition phase begins. In this phase, The macrophages of the liver, lung, peritoneal cavity, spleen, as well as mast cells and Langerhans cells in the epithelial tissue recognize this induction through specialized receptors present on their surfaces, including scavenger receptors that recognize damage-associated molecular patterns and toll-like receptors that recognize pathogen-associated molecular patterns. After the macrophages recognize these molecular patterns, they start releasing mediators like TNF and interleukin 1. These mediators perform three major functions. First, they act on endothelial cell to express adhesion molecules like selectin. These selectin recruit neutrophil from the blood to the site of inflammation. Second, they stimulate liver to produce acute phase reactant like mannose binding lectin that activate complement proteins. These complement proteins bring about enhanced opsonization, cytolysis by the formation of membrane attack complex, and degranulation of mast cells, resulting in the release of histamine, which causes vasodilation and endothelial retraction. In addition, these mediators also travel to the brain and induce fever. The endothelial retraction caused by the release of histamine allows more neutrophil and plasma albumin to reach the site of inflammation. The plasma albumin draws water into the tissue, resulting in swelling or edema. After this recruitment, the removal step begins with the phagocytosis of pathogen and damaged cells by the macrophages and neutrophils. The final step is the repair process involving proliferation and remodeling. During this process, neutrophil releases cytokines and growth factor to initiate collagen formation by the fibroblast and the repair and remodeling of the epithelial barrier. In summary, inflammation is a spectrum of activity including homeostasis, physiological inflammation, pathological inflammation, and immunity, orchestrated by four main components: inducers, sensors, mediators, and effectors. And this orchestra is performed through four distinct steps: recognition, recruitment, removal, and repair. Thank you so much. Keep liking and watching.